The last type of logarithmic function we want to talk about is when we have base e. So log base e, the way we write that is natural log, okay, right here, the natural log of x. Again, its domain has to be a positive number, okay? Please don't call it ln, that makes it sound like you don't know what you're talking about, okay? So it's a natural log function. So the first thing I want you to do is pick up your calculator, make sure that we can do these in the calculator. So find the natural log button. It should be over on the left-hand side. And you're going to take the natural log of 0.01, which you should get negative 4.6. And then we're going to take the natural log of 4, get about 1.4. Then we're going to do the natural log of the square root of 3 plus 2. So the natural log of that is 1.3. On this last one, if you put natural log of -1 in your calculator, it is going to tell you domain error because you can't take the natural log of a negative number. The properties of natural logarithms are exactly the same as the properties of the other logarithms. Okay, natural log of 1 is 0 because e to the 0 is 1. The natural log of e is 1 because e to the first is e. Natural log of e to the x, those are going to cancel out, so it'll just be x, and e to the natural log of x, those cancel out, so also just x. And then here's your one-to-one property again. If you just have one natural log on each side, you can kind of ignore it and just have x equals y. So we're going to use those to simplify. So natural log of e to the 1/3, those are going to cancel out. It is just going to be 1/3. 5 times the natural log of 1, well, the natural log of 1 is 0, so 5 times 0 is 0. 3/4 times the natural log of e, natural log of e is 1, so this will just be 3/4. And then e to the natural log of 7, those are going to cancel out, and it'll just be 7. So just applying those properties. Now, the domain of these functions, remember that you cannot take the natural log of a negative number. So no matter what happens, this thing right here, 2 minus x, it's got to be greater than 0. Now you can solve this for x, no big deal. Don't forget when you divide by that -1, you have to flip the sign. So the domain on this is x is less than 2. Over here, we cannot take the natural log of a negative number, so x plus 3 has to be greater than 0. So x is greater than -3. And this one right here, x squared has to be greater than 0. Which is always going to be true, like because we're squaring something, that's always positive. So that's going to be true for all real numbers, except you actually can't plug in 0, because then it would equal 0. Okay, we can also do these using our transformations. Let's come back to b. Remember, the graph of natural log is going to look like this. Domain is x is greater than 0. This transformation here is moving it left 3. So we just move this whole thing left 3, including the asymptote, and it looks like this. And that's why the domain is x is greater than -3. So you can also think about these with the transformations as well. Our last problem is just some applied stuff with it. So we have the psychology experiment where you go to these lectures and then take an exam on the stuff you learned. And then every month for a year, you come back and retake the exam. We're going to see what happens to the score. So this is the function we're looking at. So we want to know the average score on the original exam. All we have to do is plug in 0, because that's the original exam, was at time 0. And when we do that, we just get 75. All right, at the end of 1 month, so we all come back 1 month later, so just plug in 1. I'll put that in the calculator. And now the average test score is 70.8. After 9 months, we're going to plug in 9. Put that in the calculator. And now the average score is 61.2. And then finally, at the end of 12 months is when this experiment ends. 59.6. So you can see as time goes on, we're forgetting more and more of this information, but our forgetfulness tends to slow down a little bit with this natural log function.